Hi, in this video I'm looking at this question here where we've got Ashton starting a new job and his employer sets up a super account for him, and that employer deposits $450 at the start of each month into that account. The account earns 8.2% per annum compounded monthly, and we want to determine the balance of that super account after 3 and 20 years. So to do this problem, we actually need to think about what's going on with the super account. What happens is that in the first month there is $450 deposited, and then that month goes for a bit, and then some interest is calculated, and that increases the value up on the account a little bit. But then another $450 is added, the month goes on a bit, we add some more interest, and then so that increases it, and then another $450 is deposited, so the balance goes up some more, and so on. Now, because the first deposit happens before there's any interest, the way you calculate this changes, because normally an annuity, if we want to find the future value, is based on the fact that the deposit is made after or at about the same time as the interest is calculated. And the rule for if the interest is calculated, then the deposit is made for the future value, gives us that the future value is A equals M outside of 1 plus I to the N minus 1 over I. But because there's this little bit added in at the beginning, that requires us to also use a slightly different rule, because this bit acts as an initial investment which then gets interest added to it over time. And an initial investment that gets added interest to it over time is compound interest, which is A equals P outside of 1 plus I to the N. And so we actually want to join these two rules together, and overall we're going to have the rule that we're going to have our final amount after, in this case, 3 or 20 years, is going to be our compound interest plus our future value. So we're going to use these two put together to make one overall rule, and this is how you do calculate superannuation, or any annuity, where the value, the deposit, is done at the start of the month, where normally they're done at the end of the month. And superannuation is an example of this. Also, any annuity where there's already an amount there. So a super account where maybe you're transferring some money from one account into a new account, so you've already got some money. Or any annuity where perhaps you've got an initial investment you're going to put in, and then you're going to add in a little bit after that. So let's go and have a look at the numbers we're going to put into this. So A is going to be our final amount. It's our target. It's our final amount that we're after the periods are over. P is the initial investment, and for us that is our initial deposit. So P is going to be $450. I, which turns up a couple of times in this rule, is of course our interest. And our interest in this question is 8.2, but that's a percentage, and we need that as a decimal, so we've got to manipulate this, and we're going to divide it by 100 to turn it into a decimal, and we're going to divide it by 12 because we're compounding monthly and there's 12 months in a year. So we're going to divide by 100 and divide by 12. And just for simplicity's sake, we're just going to leave that as the fraction 8.2 over 1200. And that's just because this ends up being a reasonably ugly decimal that has lots of decimal places, so we'd end up rounding it and having a rounding error, and we don't want that. M is next, and M is the periodic payment. It's how much is being made each period, and that is our $450 in this case. N, little n, I'm not going to work out yet, because that's based on how many periods there are. So let's go and do part A, which was 3 years. How much is this super account going to have in it after 3 years? And this is where I'm going to work out n, because all these values are going to be the same. It doesn't matter which period whether I'm doing 3 years or 10 years or 20 years or 100 years. We're still going to have the same initial investment, the same interest rate, and the same deposit. But n is going to be how many periods there are in 3 years. And because it's happening monthly, so we've got 3 lots of 12, so we've got 36 periods. So now I can go and put all of our numbers into the rule, and so our rule states that we're going to have our final amount A, which is going to be our principal, 450, multiplied by 1 plus I, which is the 8.2 over 1200, all to the power of n, which is 36, so we're going to have to the power of 36. Then we're going to plus on m, our deposit, 450, and multiply by this fraction, 1 plus our I again, which is 8.2 over 1200, to the power of n again. We have n again, so we have to the power of 36. There's a minus 1, that's not part of the bracket or the power. And then we're going to divide by 8.2 over 1200, our I. So now we need to put all of this neatly and tidily into a calculator. So let's have a look at how that's done. So if we can do this nicely, we can make it so that we don't make any mistakes. And these calculators, the scientifics, tend to be able to make it quite nicely, at least newer ones. So we have 450 times 1 plus 8.2 over 1200. We have to arrow outside that fraction, to the power of, and we want to the power of 36. I've got to arrow out of the power, plus, so I'm up to here now, this 450 bracket. Now there's this big fraction there, so I'm going to put that fraction in first. I'm going to have bracket 1 plus 8.2 over 1200. Arrow outside of that fraction, close the bracket, to the power of 36. I've got to have the minus 1, but it's not in the power, so I've got to arrow out of the power, minus 1. And then I come down to our denominator, and we've got the fraction 8.2 over 1200 there. Arrow out of the fraction, arrow out of the fraction, close the bracket. So if we skip through this, we can actually see that it more or less looks the same as what we've written, which is a nice thing about modern new scientific calculators. Press equals, and we find out our answer is that our final amount after 3 years is that there will be $18,571.14 in the account. Now we want to do this for 20 years this time. So we are going to do part B, which is for 20 years, which means that our N is going to be 20 years worth of 12 months. So we have 20 times 12, so that gives us 240 periods. And so now we're going to go through the rule again and just change N. Everything else stays the same. So we're going to have A is going to be 450 multiplied by 1 plus 8.2 over 1200 to the power of n. And so n changes here, we're going to have to the power of 240 plus 450 times by 1 plus 8.2 over 1200 to the power of n, so that's the only bit that's going to change, 240 minus 1 over, again, our I, 8.2 over 1200. So now I've got to go and put all of this into the calculator. But that's okay, we're using a nice new modern scientific calculator. And that actually helps us again, because I can arrow through our rule here, and because the only thing I need to change is our power. So I can go up to the power, delete it, and replace it with 240. And then I've just got to go through to where the other power is, just a little bit further back, delete it, 240, press equals, and we've got our answer. At the end of 20 years, there will be $274,051.67 in the account. So there we go. If you're asked to find the amount at the end of the superannuation, especially considering superannuation has the deposit at the start of each month, which makes things a little bit tricky, you're going to use the compound interest rule plus the future value rule, work out all your numbers, and plug them in, being careful with how you put them in your calculator.